Hello everyone. Now today we are going to see the advantages and the disadvantages of Apriori algorithm. In the previous session we have covered the topic that Apriori algorithm, and we have also seen the examples on this. Now today we are going to see what are the advantages and the disadvantages of Apriori algorithm. So moving forward, here we have mentioned some advantages and the disadvantages of Apriori algorithm. The list of advantages contains the three advantages. The first is large item set property is used while implementing. So whatever the transaction data we are choosing to find out the frequent patterns over there in the transaction table. So it may happen that the large item set property we need to use while we are implementing such a Apriori algorithm. Again, the parallel implementation we can do by using this Apriori algorithm, and it is very easy to implement this Apriori algorithm to finding out the frequent patterns in the data set, because here we are applying the steps of 1 frequent, 2 frequent up to the k frequent, and we are taking them in the looping while we are calculating this frequency. And after calculating the frequency, what we do is that we are finding out there what is the frequency count of that pattern. For a 2 frequent, we are taking the matching the pair of the 2 item sets, then we are calculating the frequency count of that, and again we are going to check over there that what will be the whether they are frequent or not by checking with them or by comparing with them with the minimum support. And after that we are removing the items which are not fit in this frequent item patterns. That means item sets which are having their frequency count less than the minimum frequency or minimum support count, then we are not considering these items, and we are just removing such items, and according to that our list will get small and small, and then we are implementing. So its implementation is little bit easy as we consider it as a item is frequent or non-frequent. So these are what the advantages we are having regarding this Apriori algorithm. With this disadvantages we are also having some with this advantages we are also having some disadvantages over here, and the disadvantages are listed here. That this algorithm is easy to implement, that we have seen that, but it needs a lot of scans which make it is a cumbersome. Means what that we are having the different scanning, that whether they are following the minimum frequency count, and after that one more scanning is required. That is nothing but we are checking for the subset. Means a particular item set, if we want to say that item set is a frequent or not, then we need to check it's a subset or a frequent or not. If our item set is too much large, and if it is having the number of more number of the subsets, then we need to check that each and every subset is a frequent or not. If any one of the subset is not a frequent, then that item set is not a frequent, and this task is takes the lot of scans for doing such a thing. So it may happen that if we are having the 10 subsets, so first 9 will be the frequent set, but the 10th number subset will be infrequent. So it wastes the time of searching all that frequent subset. So it may happen, and that's why we require the lots of scanning over there while we are implementing this Apriori algorithm, and this make it somewhat difficult over there, time consuming process. Then the next is we require the more memory as multiple scans are required. So as we are saying that we are taking the multiple scan over there to check whether they are satisfying the minimum support count. After that we are checking whether their subsets are frequent or not. So multiple scans are required, and it is going to be performed in the loop, and as we are doing is in the looping structure, so it will require the much memory, and definitely after requiring such a memory it will make a big impact on our implementation. So these are what the two disadvantages are regarding the lots of scanning is required, and due to this lots of scanning we require the more memory to do such a thing. So these are things according to the disadvantages and advantages. Now we are going to see what the improving the efficiency of Apriori, what we need to do. But before that, we just see the algorithm first, because in this algorithm we need to do some changes. That suggestions are provided over there. So first we are going to revise this algorithm, and then we'll see the next changes. So for this a priori, what is the thing is that we are considering the candidate list, that is what the one list, and again we are having the another list from where we are choosing the atom which are frequent by comparing with them into the by comparing with these items with the minimum support count. So we are using the two list. One is a candidate list, it is in terms of C, and one is the list that is in terms of L. That L is going to be show you the frequent item sets by checking its minimum support count, and the C is nothing but they are a candidate set, means they are a generated list of the candidate sets they are going to show. So these items are frequent or not, that we are going to check by using this frequent subset item set. So initially we require the one frequent, means item single item we are checking with the L1 list, a single item. That's why we are saying that frequent one item set we are choosing, and then from k is equal to 2 we are going to apply the looping construct. So for L1 we are finding what are the frequency count of that list, and after that from k is equal to 2 we are going to generate the a priori set. So how we are going to generate that? So here for each item sets we are checking that whether that item is available in the list 1 also and the list 2 also. So according to that comparison, then we are going to join that two steps, that two list L1 and L2, when we are finding out the matching elements over there. And then we are saying that if the elements are matching and it is present in the previous list also and the current list also, then we are saying that yes, its subset is a frequent, so that atom can be a frequent. If its subset is not a frequent, then we say that atom is not a frequent. So in this way we are generating a priori over here, and after that we are checking for the each subset. If that subset is available in our previous table, then we are saying that yes, it is a frequent item sets, and we are adding that frequent item set into our list of table. So according to this we are generating our L1, L2, L3, and for using for generation of this L1, L2, L3 we require our candidate list C1, C2 and C3. So in this way we are generating the list of the items depending upon their minimum frequency count satisfaction. With that we are also checking for their subset are frequent or not, and by looking this all concept, finally we get the list of the frequent item at the end. There may be 3 frequent, 4 frequent likewise. So this is what the a priori algorithm that we have seen previously. We have also seen the examples on that. Now we are going to see that what are the improving methods are there for improving the efficiency of a priori algorithm. So there are many variations that we are having for the a priori algorithm that are proposed for improving the efficiency of a priori. So some terms are given here, that hash based item set counting, then transaction reduction, partitioning, sampling, and the dynamic item sets counting. So these are the list are given that can be used for improving the efficiency of a priori algorithm. So what we have said, that disadvantages that that we are needed the more scanning for this a priori. If our data set is very large, then this scanning will require the more memory likewise. So these are some disadvantages. So if you want to improve such a thing, so what we can do, so the list of items are given here. So let's see it one by one. So starting with the very first technique, that is a hash based item set counting. So its name is indicating that we are going to use the hashing over here. The item sets can be hashed into the corresponding buckets. So we need to here use the hashing concept. For a particular iteration, if you are taking the k item set, that is from 1 frequent, 2 frequent, 3 frequent, like 1 item set, 2 item set likewise, they can be generated, and they, after the generation of that list, we are hashed them into the respective bucket and will increase the bucket count. Means we are generating them as a like one frequent, 2 frequent and 3 frequent item sets we are having. So according to that item sets we are going to generate the buckets also. Means one bucket, two bucket, and according to your k item sets we are putting or we are hashing them into their respective buckets. So if we are doing so, then count of bucket is going to be increased. The bucket with the count lesser than the support should not be considered as a candidate set. So in this way we are going to search, means whatever the bucket we have chosen or in which bucket we have put it, that if the count of that bucket is less than the minimum support threshold that are given with the example, if that is less, then we are not going to consider that bucket as a candidate set. So this is what the one technique that we can do when we are using the iteration of our k item sets. So we can hash them into the bucket with their respective bucket, and as per this we can increase the count of bucket. So this is what the one technique, that hash based item set counting. Now the another, that is nothing but a transaction reduction. So what is the transaction reduction is, a transaction that does not contain k frequent item set will never have the k plus 1 frequent item set. Such a transaction should be removed from future scan. Definitely, whenever we are saying that in our algorithm that we are checking for a subset, means what, if the subset is a frequent, then their superset is going to be frequent. So same thing we are seeing in this transaction reduction, that if that item set or the transaction of the k frequent item is not infrequent, then the k plus 1 is also not going to be frequent, and such a thing we have to remove from our transaction. As the subset is not frequent, then its superset is also not going to be frequent. So in this way we can reduce that transaction, and if we are reducing such a transaction, then the future scanning, whatever the data is remaining in that transaction, that scanning is going to be less over there. So this is what the transaction reduction we can do, that says that a transaction that does not contain the k frequent item set will never have the k plus 1 frequent item set. Means if the subset is not a frequent, then its superset is also not going to be frequent. So in this way we can reduce such a transaction, and which is ultimately reducing the scanning that is required in future. Then next is a partitioning. Partitioning the data, we are going to find the partitioning of the data. We are doing this partitioning to find out our candidate item set. This partitioning consists of the two phases. In the phase 1, the algorithm will divide the transaction of that data set D into the overlapping partitions. We are going to divide them into the overlapping partitions, and then minimum support is the minimum relative support threshold. Then the minimum support count for the partition is the minimum support into the number of transactions in that partition. So it is ultimately going to reduce the count, as your minimum support count will be very less compared to that when you are dividing your transaction data set into the overlapping partitions. So according to that partition and what are the number of transactions in that partition, according to that your minimum support count is also going to be reduced. So this is what the phase 1, and the local frequent item set may or may not be frequent with respect to the entire database. However, the frequent item set from that database has to be frequent at least for one partition. Suppose we are doing the partitioning of the different databases. So it may happen that the particular item set is a frequent for that partition only, but it is not a frequent for the whole database. So such a frequent item set is called as a local frequent, because it is only frequent for that particular partition, but it is infrequent for that entire database. And the global candidate item set is nothing but that is frequent from all the partition, means that set will be frequent for their partition, for other partition, and for whole the database. That is called as a global frequent item set, or you can say the global candidate item. So this term is very important here, that local frequent and global candidate item. Local frequent means they are going to be frequent for at least their own partitions. It may happen that it is not a frequent, may or may not be frequent for that whole entire database. And the global candidates item set is a collection of the frequent item sets from all the partitions. So this is what the phase 1, that we are doing the partitioning, and in phase 2 another scan of that data transaction set is performed using a actual support of each candidate is determined. So according to the support count, we can scan our whole data set for that candidate that we have found out with the global candidate item sets. For this candidate, we can calculate the actual support count of this candidate item sets. So this is what the partitioning technique we can use for this. With this partitioning, we can also have the sampling technique. So what the sampling is saying? Sampling is nothing but finding the frequent item sets in the entire database D, rather than finding the frequent item set in whole the data sets. If what happen if we are going to find out in the some samples. So how we are selecting the samples? We are taking the subset of transaction that we are picking from the whole databases, and we are searched for the frequent item in that transactions only, that in picked samples only. So if we are doing so, then definitely the minimum threshold whatever we are required, that will be reduces possibly of missing the actual frequent item set due to the higher support count. So whenever we are doing our lower threshold of minimum support, then this will reduce the possibility of the missing of the actual frequent item set due to the higher support count. It may happen that if the support count is increases, then some of the frequent items are also missed. Means what? If we are taking the support count is equal to 4, but the items which are comes at a 3 times in that data set, it is also get missed due to their higher support count. They are frequent, but they are get missed because the support count threshold is mentioned as a 4, and that's why it may happen sometimes. So it will be always beneficial that the we should have the lower threshold minimum support count. And when we can have this, when we are reducing the data set size, when we are taking the sample from our transaction, then it can happen. And the last one is that dynamic set item set counting. What it says, the database is divided into the blocks and is marked by the start points. It maintains a count so far, and if this count so far crosses the minimum support, then item set is added to the frequent item set collection, which can be further used to generate the longer candidate item sets. So it is also very easy to do that if we are dividing our data set into the number of blocks, okay, and it will have their own count. Whatever mentioned with that blocks, they are going to maintain their own frequency count, and if this count of frequency we need to update it as we are using that data, and if this count crosses our minimum support count, then automatically we are going to add that particular block or the data in the block into the frequent item set collection, which can be further we are using for the to generate the candidate set. So this is also the easy method while we are improving the efficiency of Apriori algorithm. So here we are finished with this improving technique for the improving the efficiency of our Apriori algorithm. So these are the 5 techniques that are enlisted here. That hash based item, here you can use one hashing with the bucket, and in the transaction reduction, here you can reduce the transaction. Ultimately it is going to be increase your processing speed and scanning. Then partitioning, you can partition the data, and according to that partition you can find out the local frequent and the global frequent items. And in sampling techniques, no need to search in the whole data set, but if we are creating the samples over there, then it will be very easy. And while sampling, again the minimum support threshold is also get reduced, and if we are having the less threshold, then there is a chances of item to be frequent more. And the last one is the dynamic item set counting. Here we are dividing the data into the blocks, and according to that blocks we are considering that they are maintaining a count, and if they passes or that crosses the minimum support count, then we are going to convert them into the frequent item set collection, which can be further used for the generation of a candidate item sets. So with this thing of an Apriori, that is advantages and disadvantages of Apriori algorithm, and what are the different measures we can do to improve the efficiency of that Apriori algorithm, that we have seen the 5 steps are given there, that the 5 techniques are given there, and with that technique we can improve the efficiency of Apriori algorithm. So this Apriori is very important as far as we are concerned related to the frequent item set. It is very easy, but only the scanning is required more for doing so, and that's why we have provided the efficient techniques if we want to remove such a large scanning. So today we are stopping here with this Apriori algorithm, advantages and disadvantages, and many more things about that. So thank you very much.